A term that you might hear from time to time is HVAC or HVAC. It's an acronym for heating, ventilation and air conditioning. And as we can see from the image on the slide, at a large data center, these systems can be huge and truly industrial scale. We're not talking here about a little mobile dehumidifier or aircon unit that you wheel in on a trolley and plug into a power socket on the wall. In large data centers, HVAC systems are huge and complicated. Another term that you might hear bandied around is M&E. This one's an acronym for mechanical and electrical and refers to the obvious mechanical and electrical components of a data center. That's the power systems, motor generators like diesel generators that generate power when the feed from the power company's out, UPS systems, aircon, basically anything of a mechanical or electrical nature. This time the image on the slide shows a large diesel generator outside of a data center. This diesel generator can generate several hours worth of power for the data center in the event of emergencies where mains power supplies are compromised. We also talked briefly about raised floors. Raised floors are common in data centers as they allow power and network cabling kit to be kept neatly out of the way. It's common for power to IT kit to be provided by 16 amp, 32 amp or 64 amp commando sockets that are placed in the floor void beneath the data center racks. These power feeds then have armoured cables all the way back to the PDUs that we showed earlier in our floor plan, where each cabinet is individually fed and fused with a breaker so that each can be individually isolated. But raised floors are made by resting square floor tiles on top of metal stilts, meaning that you need to be careful how much weight or load that you place on them. Make sure that the equipment you stand on them isn't too heavy for them, as raised floors absolutely can collapse if you put too much weight on them. Also on the topic of power floor and racks, it's important that IT kit is properly grounded. And by kit we mean racks, cable ladders, cable trays, basically anything metallic. Providing a direct path to ground for electrical equipment is general good practice, as it helps avoid things like static build-up and protects staff from potential harm. When it comes to grounding, make sure that you comply with local laws and equipment best practices. It's also best practice when working with kit in the data center to wear anti-static wristbands or use other recommended equipment to protect your IT equipment from damage due to static electricity. Then there's cabling. We probably shouldn't have left this to the end, as cabling is a major part of data center design and operation. Get the cabling wrong and you're gonna end up in a world of hurt. As simple as that. It's tragic how often an IT problem boils down to a bad cable. Bend a fiber cable too tight and you'll break the glass inside. Run a copper cable too far, beyond its recommended distance for any given category and technology, and you'll get all kinds of signal related issues. Let your cabling get messy and any future work adding or troubleshooting cables becomes a nightmare and carries increased risk of error. Good cabling is an art, and a well-cabled data center can be a work of art. The term structured cabling refers to well-planned cabling, and it's the opposite to spontaneous or ad hoc cabling. Technically speaking, structured cabling in anything other than a small data center is a job and a profession of its own, and beyond the scope of this course. It involves a main distribution area where core networking equipment resides, as well as cross-connects, multiple horizontal distribution areas, and plenty more. But what is of importance to us is the use of patch panels. Patch panels allow for tidier, easier, and safer cable management than if we were to run cables directly from service to switches and switches to storage. For example, instead of having to put your hands in near the back of a server, switch or storage array every time you want to fiddle around with cabling, we can often do most of the work at the patch panel, lowering the risk of things like knocking out the power supply to kit. And last but not least, fire suppression. Not a sexy topic, but an important one. Data centers will be equipped with fire prevention, fire warning, and fire suppression systems. Fire suppression systems will range from the small handheld fire extinguishers that we're all probably familiar with, all the way up to overhead water sprinklers and gas-based systems. The gas-based systems usually either starve the fire of oxygen or drop the temperature in the room so low that the fire struggles to survive. And generally speaking, gas-based systems are the best choice, as they're less likely to destroy your kit as well as the fire. Basically, they don't hose everything down with massive amounts of water. After all, water and electrical equipment tend not to mix that well. So, although a water-based fire suppression system might well put your fire out, it also stands a good chance of ruining a bunch of your equipment too. You get what you pay for, really, and gas-based systems tend to be the most expensive. And that concludes our lesson on converged networking and the data center. My name is Nigel Poulton, and I've been your instructor for this lesson.